The image you are looking at is called the Hubble Legacy Field. At first glance, this image looks quite normal. Some galaxies, a few lights, nothing special. Galaxies like these existing in the universe is completely common. But when scientists analyze this image more closely, a shocking fact comes out. This image is from one of those regions of space that we almost considered empty. Meaning, places where we thought there would be nothing here. Thousands of galaxies were hidden there as well. And even then, this image is almost nothing compared to the real scale of the universe. In 1990, when the Hubble Space Telescope was launched, some scientists genuinely believed that Hubble would be so powerful that we might even capture the edge of the universe. But Hubble turned out to be just a trailer. After that came the Compton Gamma Ray Observatory, the Chandra X-ray Observatory, the James Webb Space Telescope. And even today, all of them together have not been able to find the edge of the universe. The more we keep looking, the bigger the universe keeps getting. So at this point, a common doubt naturally comes up. Does the universe really have an actual end, or is the edge just a human imagination? So look, the universe is not like a mountain cliff where on one side there is a complete abyss. This statement is slightly wrong. First, understand what an edge actually means. An edge would be a place where everything just ends, like the end of a video game map. But in the case of the universe, an edge is not realistic. An observable limit makes more sense. The observable limit is the point up to which we can see. This is an edge, but it is the limit of our vision, not of the universe itself. Einstein explained that the universe can be finite without having an edge, like the surface of the Earth. On Earth, no matter how much you walk, you never reach an edge, yet its area is finite. The universe could be similar. Instead of simple 3D space, it could be closed with a 4D curvature. If that is true, then there is no edge, but the size is still finite. According to today's observations, the universe appears flat or very close to flat. The edge of our observable universe is about 46.5 billion light-years away. Anything beyond that has not had enough time to send its light to us yet, which is why we cannot see it. But that edge is our limitation, not the universe's. And the next question naturally follows. How much of the universe can we see versus how big the universe actually is? You must have studied the speed of light in school. When light reaches us, we are able to observe it. If there is light traveling toward us and we can see and analyze it, that's the basic concept of light. But light also has a fixed speed limit, and it cannot go beyond this limit. It's approximately 186,282 miles per second. That looks like a huge number, but on the scale of the universe, it's nothing. For example, if your friend is on Mars and you are on Earth, you can never talk in real time. Because even if you send a message, it would take about 7 to 20 minutes to reach them. No matter how advanced the technology is, no one can break this rule of physics. The most distant galaxy discovered so far is MOM Z14, which is about 13.53 billion light-years away from us. That means its light took 13.53 billion years to reach us. This does not mean the galaxy is currently 13 billion light-years away. It means its light is reaching us now. At present, this galaxy would be about 33.8 billion light-years away from us. So the pattern is clear. What we are seeing is its past version, and whether it still exists right now or not, no one knows. The entire universe works like this. The light we see has already reached us. Where those objects are in real time and what they are like now, no one truly knows. So the actual universe is different, and what we have seen is the observable universe. So look, we already figured out that technically the universe does not have an edge. Then where does the universe actually end? In a short answer, the universe has no end. For example, if you sat in a spacecraft and set out to find the end of the universe, and even if you reached that galaxy after 13 billion years, by that time the universe would have expanded another 13 billion light-years. So does that mean the universe is expanding at 1 light-second per second? Actually, the universe does not have a fixed expansion speed. The universe itself does not expand in the usual sense. Instead, the space between two objects stretches. And there is a simple rule for this called the Hubble constant. It says that for every 1 megaparsec of distance, the expansion speed is about 70 kilometers per second. That means if a galaxy is 1 megaparsec away from us, it is moving away from us at 70 kilometers per second. In reality, it is not moving by itself. The space between that galaxy and us is stretching at that speed, pushing us apart. But now you might have a doubt. What is a megaparsec? A megaparsec is a unit used to measure distances in the universe. Just like we use kilometers or miles on Earth, in astronomy, we use the unit parsec to measure cosmic distances. And 1 parsec equals 3.26 light years. That is around 30.9 trillion kilometers or 19.2 trillion miles. And 1 megaparsec means 1 million parsecs, which equals 3.26 million light years. So for every 3.26 million light years of distance, the recession speed increases by 70 kilometers per second. According to this, if MOM Z14 is 13.53 billion light years away from us, that means it is about 4,150 megaparsecs away. If we multiply that by 70, its recession speed comes out to about 290,500 kilometers per second. That is about 97% of the speed of light. If that galaxy were 14.5 billion light years away from us, its recession speed would equal the speed of light. That would mean its light would never reach us. And this is the key point to understand, because there can still be galaxies or stars beyond 14.5 billion light years. The difference is that even if their light travels toward us at the speed of light, we would never be able to see it. For example, if you are driving a car and another car is following you, and both cars are moving at speed c, and the driver behind shoots a bullet that also travels at speed c, then the space between you would never be covered unless the cars slow down. We're trying to find the age of the universe, but by the time we zoom in to look for the edge would have moved 2 or 3 times farther away. So now the question comes back to the same point. Where is the edge of the universe? The truth is, maybe the universe doesn't have a traditional edge at all. What we were calling the edge was actually the limit of the observable universe, a visual boundary, not a physical one. The universe could be infinite. It could be finite. It could be curved. It could be flat. But one thing is clear. Even if an edge exists, it would not be like a wall, where you go and suddenly stop. And maybe the most interesting thing is, the problem is not the edge of the universe. The problem is the edge of our understanding. Our physics is not complete yet. Our measurements are limited. Even our imagination is limited to 3D. Maybe future telescopes and deep space missions will give us more clarity about the shape of the universe. Maybe the answer will turn out to be something completely different. And maybe this mystery will never truly end, because the greatest feature of space is not its size, it is its mystery, and maybe that mystery is the reason we never stop looking.